Welcome back to the lab. It's Thursday Arvo. We're, I think, 7 weeks away from season opener for NZ Super Lap Series for this thing here. There's work been happening on that behind us there, Abby the Barina, but it's a little bit boring, a little bit time consuming and smelly and yucky. So this afternoon I'm going to crack on with something else we need done on that to get that off the hoist so we can put that on the hoist. It's quite hard to do backwards in the mirror image, and carry on, finish that up. And it's all very twisted and juggly and fun. So we kind of need, well, we do need at least one flange adapter type dooflicky thingy that looks a little bit like that one. We can put that one back on the transfer box, and that's fine. And then we just need one more. So I've got that one more on the spinny roundy thing here, which I've actually cleaned and adjusted things to make sure it's going to do a nice job. Realistically, it's probably a better bet just to pay someone to smash it on their CNC machine and blup, and it'll be done and look a bit like that, except the 4-bolt pattern come in from the other side for the gearbox flange. But I'm going to press on ahead with this because I'll be able to just carry on working through the weekend getting it done, whereas if I send it off to our mates at Kimberley Tool and Design, it's going to be on couriers for, who knows, probably a couple of days each way. So we'll lose 4 days of calendar time, plus the time to find for them to find the time to do the job. Even if they did it straight away and then got it back on the courier, it's going to be gone at least a week, and then we'll only have 6 weeks until Super Lap or whatever. So I'm just going to crack on with it and get it done. It's not too bad to get everything in exactly the right spot as long as you follow the right process. So let's get this cranking up. It's a bit hard to clock this up accurately to start with because the outside surface of it is beaten to death. That's fine, that's what happens. So for now, I'll just use the 3-jaw chuck and do everything on this side, and that's all fine. It'll be all centered. When we flip it over to do the other side of it, we're going to have to put it in the 4-jaw chuck and clock it up with the DTI because I'm not happy with the accuracy of that. It's out by more than what I'm happy with. I can get it better with the 4-jaw chuck and the DTI. So that's how we'll be going about that. Jump. Probably take 2 or 3 cuts on that, I would think. Pretty rough on that end. Alright, that's called facing it off or whatever, because we've put a face on here. Hey, look at that. It doesn't look that great, does it? Like that. Then you put your finger there. It's not bad. Not bad, good size. Don't worry about that. This is 130 diameter. We're taking it down to, off the top of my head, it's 118 or something like that. So there's a whole lot comes off the outside of this. The first thing I'm going to do is do the spigot. The spigot, the bit that goes in there, because that's the important bit. As long as you've got everything running true to that, then you're good as gold. Or shiny billet polished aluminium, as the case may be. Fun! Cool, no one has died so far. So that's the spigot done. It's faced off. It's down to the right outside diameter for this end, the gearbox end of this. I'll taper it down at the other end. We've got some bolts coming through here. I want nice thick amount of material around the outside edge so that we don't get any elongation and bolts coming loose and then explosions. A little bit of a mess on the floor. A lot of a mess on the floor. It's a pity we can't recycle that, but whatever. If I'd made it the same outside diameter as that, I'm just concerned that this is pretty minimal sort of thickness here, especially because we're aluminium. It is 7075, it's the same stuff as this. It's really good, strong stuff. It's stronger than some grades of steel, but I want a bit more than that. So I think this is 115 off the top of my head. I've made that on the machine 120 diameter, so we've just got a little bit more material there, a bit more guts, a bit more strength in it. When that's cooled down, I'll check the dimensions again. It's obviously gets a bit hot in the machine, a little bit hotter than what you can hold on to, so we haven't affected the temper of it or anything like that, but I'll double check those dimensions, because basically once that comes out of there, I don't want to be trying to muck around with this side again. That's when you get errors happening. 4-jaw chuck. Oh, you might not be able to see that, but there it's clocked up pretty damn good. Next we got to do, get rid of this lip here, that can go away, and probably put a little bit of chamfer in, and dig out all this end, make it look a bit like that, sort of, not quite like that. We're doing something just a little bit different, but it'll be similar. Sorry guys, I didn't film much of that part. It was rather boring. Ha. 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 That's the basics of what we need to chew out is done. It'll work. It's going to be heavy. We need to put some holes in it. 6 on that side at whatever the PCD is, I can't remember, 90 or something like that. That's 108 to the outside of there. That needs deburring, doesn't it? And then 4 on the other side on a funny pattern. It's a rectangular pattern, it's not a square pattern, square PCD or whatever. Might flip this around, clock it up and bore that through, because there's just a lot of weight sitting here that doesn't need to be here. It's not a lot of weight, rather it's percentage wise for this it's a lot, but it won't be much in total. So I might do that before I start drilling holes. Well, that's pretty good. It's a nice snug fit. Goes roundy roundy. It's good. As you can see, there's no bolts holding that. Gotta give it a bit of a yank to get that off there, so that's good. This is this not square pattern that I've got to put onto that side. That's fine. Other side is actually pretty simple, really. I'll get one of my, this is one of the good, this is the $500 expensive CV joint, so I'll pick one of these puppies under here that's not all full of grease. Nope, probably that one. We just need to sit that in there, set up the drill press and find a drill that's the right size to stick it in there and not wobble around, and we can mark all the spots that we need to drill and tap our threads, and that will be perfect. That'll be fine. I mean, you can use a rotary table. I've got one, it's itty bitty. Here's a rotary table. This is the tiniest rotary table in the world. Not quite, but it's far too small for doing these things. It's good for doing other things. You unlock this screw here and then you turn this handle and the table goes around, and you can see how many degrees you've moved it, and you can do all your holes that way. Set it all up in the mill drill or a drill press or whatever, and do that. But we're not doing that because that's too small, like I say, and we don't need to, because this technique that I'm going to use, it would be absolutely perfect. Right, let's do that. Burning the day up real fast. Cunning trick, eh? So I've used that. That's the actually a 3-jaw chuck out of the lathe because we've got the 4-jaw in there. But you could take this off anyway. If most lathes only hold on by 3 or 4 bolts or something, so you take that off, and then you can hold round things really easily, and it gives you a really big flat surface that's square. Put it in your drill press and make sure all your holes are all square. Then when you've drilled all your holes, you put your tap in the chuck like that. I'm surprised it did that through the lens of the camera actually. And then you can start all your threads in there and get them all nice and square. Because if you try and do those by hand, guaranteed they're going to be crooked and bad things will happen. I should clarify that when I said you use a drill press to get the thread started, you turn the chuck by hand. Okay? Don't turn the drill on. Stick it in there, bad things will happen. Success! All the bolts go in with no issues, so that's good. And that, turny, 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 turny. So, ta-da! I should probably just mark my wedding ring, whatever. Obviously that joint's upside down, right, but it's symmetrical, so it's not going to make any difference if it's in the right way or not. It cannot go in the right way at the moment because of the shape of this and the lack of doofer on the inside of here. By doofer, I mean doofer. So you'll have to watch tomorrow and see what I come up with for that. You better not be that tomorrow. Alright, thanks for watching. Cheers, bye. I forgot to show you. It was sort of most of the way there. There's still some material come out of here. And we got some new scales thanks to Wifey. 1,243 grams. I'm not sure. It might be about the same. Nope. Lighter. Quite a lot lighter already. And there's obviously a lot of material to come out of that to look like this. We won't have the bolt heads on this side. There'll just be blind holes from the other side. What was it, 1,240 or something? 400 grams, just like that. Rotating mass. All good.